Hello, everyone, and welcome to another Amplifying F# session. Today, want to talk about OpenTelemetry and how to use that in your tests. But before we do that, let me introduce you a bit more about what Amplifying F# is. So as you can see on my screen, we have a website called amplifyingfchat.io. In here, we kind of want to highlight why we're doing this. And the reason is because we want to help the ecosystem and bring new contributors or even improve, help existing contributors who are having issues completing their contributions in any open source F# project. And so, yeah, over the last more than 2 years already, we have been helping people to contribute to the F# compiler, to Visual Studio Code, Visual Studio for Windows, Fantomas, name it, all of the projects that we use daily. So yeah, if you want to be part of us, please submit a session on the website, so you can go to join us. Once you join us, you will be shown with this short form where we will ask you your name, what's the company you work for, and your time zone, all of this information, so we can schedule a meeting or a session with you, so we can help you to fix whatever you want to fix. We also ran last year an initiative called F# Essentials, which basically teaches you the essentials of F#. We partnered with Ian Russell, and we went through his book, and we had, I think, 12, 13 recorded sessions where we show you like all everything, let's say, F# related, starting from how to set up your own environment, how to use the F# core types, talking about function composition, pattern matching, and all of this good stuff. So yeah, check out that as well. For today, we have Jimmy Bird, which is our very own member of the Amplifying F# initiative, and we are going to talk about OpenTelemetry. So yeah, without further ado, I will hand it over to Jimmy.
Thank you, Edgar. I'm going to go ahead and share my screen here. All right, can you see it?
Yes.
All right. So today I'm here to talk about OpenTelemetry in your test suite. These are a set of tools that allow you to kind of get visibility into what's going on in your code. So I guess I'll do a brief start at the beginning. This is not to try to cover every aspect of OpenTelemetry. It's pretty wide, but OpenTelemetry is a specification that kind of allows your application to tell other things what is going on inside your application. And what this means is there's three pillars. There's essentially spans or traces. There is logging, which most people have some type of structured logging, and then there's metrics. The thing that we're going to be focusing on today is tracing and spans. What that kind of looks like at a high level is you can see in this example, it's called distributed traces. And so for this, you can see that you have some type of overarching request, which may be the client called some code, and then it eventually got to your backend API. And you can see what inside your backend API, where it spent its time on some type of authorization, did some payment gateway, talked to the database, talked to some external merchant, and spending a dispatch and some other calls. And you can see where you spent your time. So this gives you two things when you look at this. One, you can see where things are just taking the longest. And so you can potentially use this as a way to diagnose performance issues. The second thing is when you have an error, you can kind of get to know where this is at. That makes more sense in the context of like many applications. And so what this is looking at is potentially multiple services or programs that you may not even be in control of. So this client could be like a web app. It could also be a mobile app. This API could be a completely different backend written for something else. Talking to some authorization library, this might not even be your application anymore. You may be talking to some external OAuth provider. This DB could be Postgres, and this external merchant is some other thing that you don't even know about. Same thing with all these. You can see that something was spending time polling, doing some work, getting some information. So you can see across a wide variety of services. And so, but this doesn't mean that this isn't useful across or inside of a single process. This can still be really useful inside of a single process, seeing where things potentially could be falling down. But if anything of these, you can see where it potentially could have fell. So speaking of, or talking about that, so like how do you actually kind of get started with .NET? There's a lot of resources for this OpenTelemetry right here. And for .NET, there's a lot of words that a lot of languages will use for this kind of thing, which is traces or spans. We'll kind of get to what those are. But .NET kind of had this idea in it for a while. And you'll see it's provided to you by something called the Activity API. And so if we actually kind of look at their Get Started page, they will show you, where is their like activity? So when we actually get these traces, we'll see that there's something called an activity. .NET a while ago basically ported their activity library or internal baked into .NET, this activity, to be able to output OpenTelemetry stuff. So it's baked into .NET. You don't actually have to have an external library for creating traces. What you do have to do is have some external library for being able to push those traces somewhere that makes sense and use. If we look at here, we can see that there's some like information displayed in some console. This isn't going to be useful for us. We want some type of cute AI, or not cute AI, some cute UI that lets you see what this looks like at a higher level. And we'll touch on that in a bit, but that's kind of the primer for getting started with what this is and why it's kind of useful. So one of the things that I've been wanting to do is use this in FS Autocomplete. So FS Autocomplete is the thing that powers Ionide in the Visual Studio Code, and also powers potentially other aspects like Vim or Emacs or even Sublime Text, whoever can be a LSP compatible library or LSP compatible. But the thing is, there's a lot going on. Let me look at this Ionide IO. See what this even bring up. Yes. So when you look at the FS Autocomplete and what it all has to do, it has to talk to a lot of different things. While a lot of this stuff is in process, this is a lot. And so if we get started in the upper right corner where what you interact with, we have VS Code. And then what you do is you have a plugin or an extension that more or less allows you to turn on or off your language provider. And so this plugin then talks to the language service, which is FS Autocomplete. So right here is this, there is absolutely a boundary here between these two things. Then the FS Autocomplete has a lot of services it talks to. While these are still in process most of the time, some of them are not. One of them, for instance, would be Phantomus. Phantomus we actually talk to again over LSP. But other things like the F# compiler service, we use heavily to get type checks and be able to figure out what's wrong with your code. So all the real like hard error handling stuff is all handled in here. But this doesn't mean that this is where OpenTelemetry will actually be useful, is because sometimes the F# compiler service gives us back bad stuff. Not always, but it can. And it'd be useful to kind of figure out what's going on and seeing where is our stuff failing. Particularly when we're actually running tests. The reason I want to do this is most of our tests are integration tests, because trying to set up something where there's boundaries here, it's really difficult. You want to actually to get real valuable tests out of SOS autocomplete, we have to kind of use like real code and be able to specify like here's a example piece of code. We want the F-sharp compiler to tell us something. We get that information back and we want to translate that back to an LSP request that VS Code understands. We need to do that entire chain because if that chain doesn't work, it doesn't matter what else is going on. That particular piece has to work because the F-sharp compiler service may change how they present information, and we want to make sure that that experience is the same no matter what. And so we have potentially have tests that could fail based on any changes that come from F-sharp compiler service. Similarly, we have another thing where we talk to MS build. So we have the ionide proj info. This thing has to talk to MS build to be able to get information out of your project files. So your FS project files, those are actually not manifests. Those are files that you execute to actually get information out of. And you'll probably see loading projects when you have ionide running. That's because we actually have to talk to MS build. Now, MS build doesn't have OpenTelemetry built in just yet, but one day it will, and it'll be useful. The F-sharp compiler service actually does have OpenTelemetry built in. So what I've been doing is we use Expecto for our test suite, and what I've been doing is I've had a pull request up for a little bit. You can see it's a little old at this point, but the idea here is I'd like to actually be able to see our tests, like what's happening in our tests, because we have thousands of tests, and it'd be good to be able to potentially figure out when a test fails, what happened and why. So for instance, here's an image up. Of course, this is way too old. These images are too old, so I don't think they're going to store them. All right, so I'm going to try to zoom in, see if I get anything. But we'll see an example, a better example when I actually show the demo for this. But the idea is you still want to be able to see like where a test failed and get some information out of it. So I guess with that, I might as well go ahead and show doing just that. So the piece of code that kind of powers this is I've been working on. I basically have inlined this ability to be able to handle this. So when you write expecto tests, they basically have a root test that has a potentially different set of test cases or potentially different test lists. What we want to do is we want to inject a activity into all of these tests. And so that activity is what powers the tracing for this. And so this is the piece of code. We'll go over this in a little bit, but I just kind of want to show this example that this is the piece of code that powers this, and we run this at the high level, or we run this where all of our tests are. So if I actually just go back to this, just find this reference. We have this OTel tests thing here that I will actually look here. You can see that it ends up being used at all of our test routes. So this test route has all of our tests potentially running. Then now that I have my tests wrapped in this activity, be able to say like, hey, I want you to tell me about these things. We have to tell it where to put it. And at the very top here, there's something, I have a little function called trace provider. What this allows us to do is build a OpenTelemetry trace provider. You have to actually import or load in the OpenTelemetry SDK. And this will give us the APIs to be able to talk to, being able to push this to somewhere else. So one of the ways to configure this, you have to actually tell it which sources you want to pull from. Our application pulls from various sources. One is our self, one is FS Autocomplete itself, and one is like the test service name is the tests, and then there's also the F-sharp compiler service. Then one of the things that we have is we need to export. So this OTel exporter, there's various ways of configuring this, but for now, I'm going to actually just hard code a value, but you can use environment variables, which I'll potentially do as well. But it's like, okay, where is this thing pointing to? What is this? So I actually want to point this to potentially some type of vendor. So this is where you typically a vendor is used to host your stuff. There's there's a bunch of free stuff, but there's all kinds of paid services that you might already have access to, which is like Application Insights or Amazon's logging services. But I have a couple examples here in this Docker container that we can go through. I'll probably just point to the cute one that most people are going to be more familiar with, which is Jaeger or Aspire. There's also Seek, which is a lot of people have been using for structured logs around. But what we're going to do is stand up one of these and just kind of point out or show that this thing is going to collect these logs. And so I'm actually going to just do Docker compose. Oh, or I think I got to do profile first. I'm just going to say Aspire. Of course, I don't have. Did I spell that right? I cannot spell. Don't get spelling tips from me. Oh, of course, the Docker just crashed on me. The demo, I didn't have it open. My computer blue screened yesterday, so I had a very fun time. I did not start Docker. Give that a minute to start up. All right. Go ahead and run this. So we can see that it says it's listening on this port. This actually link doesn't take us to where we want to go. We actually want to go to this link here. Open this up. Oh, of course that is not the link that I clicked. There we go. So this is Aspire. A lot of people have been showing this off from the Microsoft team. The reason I'm choosing this is because they have three things in here that we really care about, which is structured logs, traces, and metrics. Today I'm just going to be pushing stuff into the traces here. And then I'm going to go ahead and run the tests. I'm not running all of them. Actually, I'll have a specific small amount of these tests that I'm going to be running today. And of course, it's going to take a little bit of time to build. Guess while that is taking its time. So I only have 14 tests out of like the 1,000 that we potentially have. We have 5,000 tests potentially that we run. And voila, there's data inside Aspire. So if we take a look at something that might be a little bit slightly interesting. So here's a test that took about 2 seconds. So let's take a look and see what's going on in here. This tended to be a lot of things all of a sudden. But we can see that we took a second or so. Seems like we're missing some type of initialization or something here because we're spending a lot of time in a place that we didn't get a trace. But we can see here that this whole thing took 2 seconds. At some point, we actually ended up talking to creating the F# checker, and we wanted to initialize the LSP server. So this is starting up with the, this is basically telling it, this is a LSP endpoint that says, hey, LSP server, I want you to start. So our initialization takes 180 milliseconds. Our initialize call took quite a bit of time as well. That's taken about 500 milliseconds. It's rather slow. Eventually, we end up parsing a file, and then we call the text document did open, which then also coming in here is getting the type check results. And then eventually we're going to cross into the boundary of this is still FS autocomplete. And then at this point, this boundary right here, this is where we're actually calling, or this is actually starting to become F# compiler service. I don't think they specify. I think this is something that Aspire doesn't do well. Is there's specifically another type of name that you can give your traces, and this does not specify the service name correctly. So we're not actually seeing that. This feels like a bug in Aspire. But at this point, this compute parse and check file, this is actually in the F-sharp compiler service. So we can see the F-sharp compiler service took a whole 400 milliseconds to type check this. And we can see as the F-sharp compiler service does its work, they've also been instrumenting their code here. And so we can see where a lot of this stuff spent its time. And eventually we can get to a point that's like, okay, this is so if we were looking at FS autocomplete and we're saying, okay, where could I spend some time figuring out, you know, what's why is this slow? I could potentially say, okay, I know for sure these two functions that I have are a little slow. The startup is also peculiar. Like, why are we spending quite a bit of time here before we even get to creating the checker? So we can investigate what's going on in here. But at this point where we're saying, okay, I want the text document to open, almost all of our entire time was spent in the F-sharp compiler service. So this is probably not really worth trying to optimize at this point. But at the same time, what would be interesting is if there's some type of failure. I don't have a readily made chest example for that, but let's go ahead and just throw an error in one of our tests here. So text, let's go to the state. Is there an open file? There's something like open file here. Actually, I'll start with the LSP server. Did open. So we'll call the state did open document. And here we'll potentially just go ahead and throw something. And we'll go ahead and run this again. And potentially we'll end up seeing some tests failing when we go back and look through this. Now I forget which way they sort their traces. Either the bottom is new or the top is new. Let's see if we get some failures. And we can see that there's some differences here now. We actually get this little like red indicator saying that this thing failed. And so we can actually take a look and say, okay, where did this end up failing? And we got to potentially here. And so it said text document did open, but text document worked all the way through here. And these are a lot of the F-sharp compiler stuff because we put some of our open docs here. But eventually we want to see where did this end up failing, and we can see that there's some aggregate exception, and can see that there's that message that we had something stupid happened. So we can see that somewhere in our text document open, something failed. Now, this is obviously a cute example. This seems not too big of a problem, but when you have 5,000 integration tests that you're running, sometimes CI just decides it's not going to work. And I haven't gotten to this place yet, but the one thing I want to be able to do is actually export this, be able to write this data to our tests. And when we do fail, I'll be able to load this in locally and see where are we failing, because we may still have some type of race condition that could be potentially happening. And this would actually give us the insight to figuring out why this is happening. Well, that's kind of the high-level demo view. Does anyone have any questions before I kind of dig deeper into the code and some of this other stuff that I have left to fix before we can make this like a pull request unexpected?
Yeah, you have used Expecto. How
Yep.
different would it be to use XUnit?
So I don't know who's implemented this in XUnit, but there might be someone that's Honeycomb has a blog post here about potentially how to do this. And it looks like you can implement this yourself as well, which is creating some type of fixture. And so
Yeah.
at their fixture level, you create this, and then yeah, you basically just implement some type of processor. So they have a pretty detailed example here that would go through that as well. And I'm sure there's something that exists for NUnit and MS Test and whatever test framework that you want to basically do.
Yeah. Thanks.
Yep. But the core concepts, like how to get this all working, is the same. But yeah, the very specifics are slightly different based on your test framework. All right, well, with that, then one of the things that I want to mention is how do you actually power this a little bit better with your, how do you power this in F#? So I'll touch on that before I kind of go into exactly what's left. So in FS Autocomplete, there's a little shim that I'm using called FS OpenTelemetry. And so if you've ever used if you ever used the activity API, the activities might return null. There's a whole section on why does this exist. But when you actually say like, hey, I want to get an activity, you may get a null back. And all the examples of using activity in .NET use that Elvis operator. Well, that doesn't exist in F#. And it's a little verbose to kind of handle this all manually. So what this particular file is to help out with that. So it's just a bunch of extension methods that look at like if null. So instead of just basically throwing this pattern around a lot and saying like I want to have if not null, do the thing. Otherwise, just return the span, which is null. So you get a nice, safer experience doing that. Also, there is something called semantic conventions in OpenTelemetry. I didn't touch on this specifically, but there's a lot of well-known keys that you can specify with potentially well-known values, but sometimes they're left open for whatever they are. And these allow you to allow the vendors to kind of know specific things about your traces. And so if we looked actually at, we're going to put that Aspire dashboard. So if we were looking at the very bottom here, there's a lot of these things here with these names. A lot of these are well-known names. So for instance, service name is well-known, service version, you can see the SDK name. Some of the other stuff is inside your span. So a span is an individual part, like a trace is like the entire collection of these, and a span is just one of these pieces. You can specify some extra metadata about it to help you kind of know what's going on. And in this particular case, we can specify the name. So we could actually have like a full actual name about what the span was, but we can also specify where we're at in this code file. So you could actually say, okay, here's my code path. Here is my function name. Here's what line I was on, the namespace. When we looked at that error previously down here, there's this information down here about this exception escaped type, the stack trace, and the message. These are all well-known keys. And this library also tries to help you with that. So if we look for like code.file name here, there's this code file path. This is just a literal helper. But this is a helper here that's creating source tags. So this thing will, when you actually create an activity, there's a little entry point here for starting an activity, the start activity extension. And this will try to fill out as much metadata about your environment as you can. And so when we use this, we tend to use this in, this is, it's not this one, let's say start activity for type. There's a couple of different helpers, but the one that we use here in FS Autocomplete is the start activity for type. And this allows us to, we don't have to specify the member name or path or line. This information comes from color member name, color file path, and color member attribute. These are baked into the compiler that when you have these these attributes on these parameters, it will autofill this with that information, so you can actually get it. And the key is to using inline. So this will actually put this into the specific part of your code, so that we know like where you're actually running this code. But there's a activity for type, and this one is used for being able to specify information about a type. So a lot of times you can say like, okay, here's the class that I'm in. And in FS Autocomplete, the giant wrapper that we have for LSP library is a class. But there's potentially other places you want to start this up for. And another one would be starting for functions. So if you're actually just inside a module with a bunch of functions, you don't actually have a type that you might necessarily be referring to. So this allows you to kind of use a slightly different path that will let you create information based on the function name rather than the type that you're or the class that you're in. But there's a whole bunch of semantic conventions. Let's see if I had these up, one of these tabs. Let me look for it, or I'll just search for it again. All right, let's search for it again. Semantic conventions. They have a whole semantic conventions repo here that kind of dictates what this is going to be. You can come into model and you can kind of look through a bunch of things here. There's a whole set of keys and values. So here's, for instance, code, the one I specified before. You can see that come to their common YAML, you can see what these are. So they have function name, file path, line number, column number, potentially, and stack trace. These are all, a lot of these things are optional, but you can also come in and see a bunch of different information. So if you want to get specific things about .NET, here's a lot of key value pairs that are in the .NET. So you can see like heap generation or things like that. These you probably don't care too much about, but if you're implementing some specifics, more specific things around like an interface where you're talking like JSON RPC or something like that, you may want to specify some more flags here. A lot of these things people are filling out for you, but you still may want to be able to take a look at this and see what makes sense for you to fill out as metadata that you want to be able to give yourself later. So with that, really what's left for this to be able to work in Expecto, let me go back to this Expecto test. So I guess we'll talk about the details about it in here because it'll be better to show it in tooling. So one of the things that we have to do is we have to just basically look at your tests and we have to break them apart and remap them back together. This requires this config join with, and this Expecto config comes from potentially somewhere else. The way to run Expecto is there's two different ways. You can either run it as a console program or you can actually run it in .NET Test. The entry point through .NET Test, we don't really have access to this Expecto config here. This might not be a problem because really the only thing that we're using here is the config join with. This source location thing does not work. So this particular join with is basically saying, do I specify my names with dots or slashes? You may have seen some of the output down here where the name of the test has dots in it, but it does not look like the simple example here. If I had a summary, it might spit them all out. But you could specify different ways. So we have to kind of figure out how to handle both use cases. It may not actually be a big problem in practice because most people end up doing the join with dots and not about slashes. Or if you do care, that you probably do it once and you probably don't want to specify this as like a thing that's coming from the outside. You're going to do it in one place. The last is to actually put some more documentation up about this. One of the things is I just haven't written documentation. And then we're potentially also going to be moving this into its own package. So I wrote this as kind of like, here's a proof of concept for what we want to do. And we're going to be moving this to its own package so you can pull it down and be able to just wrap your tests in this. Let's see. With that, I guess I could also show the implementation details if people are curious about that. I don't know how deep people want to get into that one. Get a yes or a no? Anybody?
I want to know more.
Okay, well, let's go in. So when you actually wrap this tests, what we're doing here is this to test list code gives us back what's called a flat list. And this is basically just all of your tests and essentially a not hierarchical view. So when you create tests, you typically have some type of like, here's my initial outside test list, which if we look at program.fs, we'll have this test list FSAC. And then potentially in here, we have another test list as general. This will be concatenated. And so this is like a hierarchical view of all your tests. So this just goes ahead and flattens that list. And what we want to do is create an activity. And so this is some helper code that is creating an activity from an activity source. This activity source is the place. This is how you teach .NET or .NET teach, I guess which way is you basically .NET allows you to create a activity from an activity source, and this is what you configure to say, I want to start exporting OpenTelemetry stuff. So back in, let's see if I pull this up at the same time. That makes sense. Back in program, OpenTel tests. So the source, we go to definition on this. There's an activity source, which is a with a service name. So this is the thing that will drive having all of your, it's kind of the same thing as like a log factory. If you've ever had to deal with any type of logging service, this is kind of the same idea. It's a factory for being able to create loggers. And later there's some, which is that eventually that configurable code here, this is all setting, this will eventually talk to that activity source, or the activity source will eventually dump that stuff out from here. The next piece here is being able to wrap your test in this. So we have this wrap code with span. So what we're doing here is we're actually creating, you'll see the terminology transfer. So really we have a span is the same as a trace, or a span is the same as a activity, I should say, because this is happening. So these are basically the same ideas. Span is what OpenTelemetry calls it. Activity is what .NET calls it. So you'll see this constantly happen where someone's referring to one thing, but they both mean the same thing. They're both referring to the same thing. And basically everyone outside .NET is going to call it a span. We're calling it, but .NET calls it an activity. So up to you whether or not you want to choose one or the other when you start calling it something, but I'll leave it up to you. So what we're doing in here is, in this particular case, we're trying to, or that's a set source location. I don't care about that one. That particular thing does not work. So this wrapped with span, basically we're handling, there's 4 different test cases that potentially could exist from test code. Let's see, they have a sync with cancel, async, and an async fs check. And so basically you have to rewrap this. And so what we're doing here is we're taking this span, we're starting it. So the start code is basically just go ahead and say, okay, this span is activated. We want to start recording information. It's disposable, so you know when this function actually ends that we want to dispose of this. So this is where the use comes from. Then we want to try our test, and if we end up with a success, we want to be able to say, okay, we want this particular outcome. And so what I'm just handling, there's setting the end time, adding an outcome. This outcome is a semantic convention for test results. So we can see the status and potentially some message about what it is. But in the error case, we want to kind of do the same things with set end time, but we potentially want to actually set the exception. And so this add exception is going to split up some information. This is basically just some parsing of the exception to kind of make the message a little bit more agreeable. And this will add it to that. This will actually create a test result that we're going to use here to actually specify or set information about it. So this will set the exception information, which when we looked at before, this is some more semantic conventions. And so we get the exception type, we get the stack trace, and if there was a message, we actually set it as well. And that's how we end up seeing that exception message in the Aspire dashboard down here. I don't know if the XUnit example that we showed has that kind of details of what they're doing there, but you'd probably want to follow a similar path if you go down implementing that yourself. And then re-raise anywhere, this is basically just re-raising an exception. So the test runner, which is expecto, knows to actually say, hey, your test actually failed. And each of these basically just does that exact thing. So we're not doing anything too special beyond that. Just more or less wrapping what happens when you pass or when you fail. And that's the implementation details of that. Let's see. I think with that, I don't really have much else to show. Does anyone have any other questions they'd like to ask?
I wanted to, I think, bring up the question I think I asked before out of the stream, which was like there are some services that will, I guess, manage some of the semantic conventions and all of that, and will use services like Serilog or these logging libraries to kind of, do that for you. Do you have experience with that?
Yeah, there's basically when you do this in real production, you want to send this to somewhere that whatever vendor that you're potentially using for like your structured logs. That's probably where you might also end up sending your traces. Like I said before, there's like application insights, but AWS has one, Google has one. That other blog I just brought up, Honeycomb, is a trace provider as well, where you can store your traces. A lot of the vendors will also have a little helper library that helps you configure sending that stuff to their particular service. That being said, you don't have to rely on their library. Specifically, if you are like if we actually take a look here, this configuration, this OTel exporter, I don't know about Aspire. I don't care about Aspire in this. I'm just sending to some generic point. But if there was like an add Aspire, I might not have to write this piece of code. There's ways of configuring this as well outside. There's like your app settings and stuff like that. There's a lot of ways you can actually get this configuration information into here, but a lot of those vendor libraries that you potentially might use do a lot of that configuration for you. So you might have to just only add an API key or something like that, and they know how to point exactly to production for you, rather than you having to wire all that up yourself. Usually those libraries are pretty simple, and if you don't want to depend on them, if you're writing something that's a little bit more generic like this, I don't really care about where I'm pointing this information to, but in your production application, maybe it just makes sense to pull down whatever package that auto configures all this stuff for you.
Cool. Thank you, Jimmy.
Have any questions on the YouTube or
Though there was
just a
just
chat now?
yeah, there was a message saying that deep dive, please. So as like you did, so
Okay, cool.
I think, yep, in the Zoom call, if no one has question, I think we can wrap it up. So thank you, Jimmy. It was a very insightful. I was, to be honest, there's, as you mentioned, there is different way of naming things that like span activity traces, structure logging, and all of these buzzwords that sometimes when you are trying to discuss or kind of trying to come up with the same description, you use the different terminology, and then you kind of the message gets a little bit doesn't go through because of that. But yeah, I think this definitely helps for us in F Sharp, because there is a clear example and clear use case, how to use OpenTelemetry, why we use it, and this kind of example and PRs are very useful for Especto and for all the F Sharp community. So yeah, thank you for that.
Yep.
Right, so let me take back the screen. So figure out where is the screen, where is the screen? Might be here. Yes, so yeah, as I said, thank you very much, Jimmy, for the session, and we will be back, I think, next week. We have another session. Next week will be Peter from the F-Sharp team, who is going to talk about his recent work on data pickling in the F-Sharp compiler. So if you want to know more about how that is possible or what that even means, pickling in the F-Sharp compiler context, join us. So yeah, you can go to amplifyingfsharp.io, click on the sessions, and we have a small description here for you to join us. Yeah, without further ado, thank you very much, everyone, and have a good weekend. And we'll wrap it here.
Thank you.